Flack math! Give me some math and I'll give you some flack. Flack math!
So this is multiplicative property of inequality. The multiplicative property of equality is whatever you do to one side, you can do to the other, right? If you multiply by 5 on the one side, you have to multiply by 5 on the other. But the only difference with the inequality is when you multiply by a negative number, you have to flip the symbol. Remember, an inequality is like the less than or greater than or less than or equal to, greater than or equal to. So everything's the same, except when you multiply or divide by a negative number, you have to flip the symbol. I'll explain it to you in a second here, but we've got, let's see here, like 8 is greater than 5, right? Any argument there? So what if we multiply both sides by negative? This is a true equation, so we can do whatever we want to it. If we multiply both equations by -1, is that true? No, it's not. Another way to think about it is I could bring the 8 over here and the 5 over there, and it becomes -5 is greater than -8. Well, that's true, right? So, but that's why you have to do it, because essentially when you multiply or divide by a negative number, you're just switching sides, okay? So you have to flip the symbol. So it's kind of one of those annoying wrenches in the plan that you just have to remember. Don't forget it. Lots of people forget it. Lots of people in other math curriculums forget it easier, because Saxon, since it's so spiral, it keeps bugging you until you go to the next curriculum, right? So it will not let you forget. But other curriculums talk about this, and then they talk about all these other things, and then they throw a test at you at the end of the year, and you have to remember this. Well, don't forget it. All right, I'm just going to do 2 examples, and then we'll move on. Okay, so let's graph x. Negative x is greater than or equal to 2. Okay, now think about this. If x is greater than or equal to 2, that means that x could be like 3, 4, 5, 6, all that, right? But negative x is greater than 2. So the opposite of x is greater than 2. That's a little weird, okay? So it has to be negative numbers, right? Because a negative can only equal a positive, and only positive numbers are greater than 2, okay? So they have to be any negative number greater than or less than or equal to -2, okay? If you think about it logically, you can figure it out. It kind of hurts your brain a little bit, but let's just apply our new rule. Divide by -1 or multiply by -1, right? If I multiply by -1, then I have to flip this. Okay, so now I've got positive x is less than or equal to -2, which makes sense because the opposite of -3, -3 is greater than or equal to 2. -4 is greater than or equal to 2. Okay? You guys understand the rule? It has to do with multiplication and division. Addition and subtraction doesn't matter, right? Because when you lift something off of this side, if you lift something off of that side, it's still that inequality, right? Or if you add something, it's still that inequality. Okay? And then, of course, they're going to have you graph it. So throw a -2 up there somewhere. Fill in the dot because it's less than or equal to, and then shade to the left. All right? So I'm going to be looking for whether you flip that. And really what I'm looking for is if you forgot to flip it, it's going to go that way. Okay? So always check your answer to make sure it works. Let's throw in like a -10. -10. What's -10? Positive 10. Is that greater than or equal to 2? Yeah, it works. 0 is 0 greater than or equal to 2? No. Yes, it is. Yeah, no, it's not. I have to keep seeing that negative. Okay, so that's not true. So you can figure out where to shade. If you're doubting yourself at all, just plug in some numbers on this side of the dot and this side of the dot and see where you should shade. Okay? All right, 2 more examples. 1 more example. 2 more examples. Okay, 4 minus x is less than or equal to 6. Okay, can you do that in your head? What's my inequality? Or do it on paper. What's my inequality? X is what? Nope. No, it's hard to do it in your head, isn't it? Or maybe you think it's easy to do in your head, but it's hard to do in your head. That's what's tricky about doing it in your head. Yes, Micah.
It is -2 and below. So -3.
No. Hey.
What up?
We were just in the middle of a problem. It's not just an awkward silence like a parent getting upset with their kids and there's that awkward silence. Maybe there's not an awkward silence in your house. Thank you.
Oh, yeah, you're welcome.
Okay, so the only rule here that's different than solving a normal equation is we have to flip the symbol. And this is the key to this lesson, Oaken. You have to flip the symbol when you multiply or divide by a negative number. Okay, you tried it in your heads, didn't work. Let's see if we can do it on paper. Ready? How do you get rid of this 4? Subtract it. So you're left with negative x is less than or equal to 2, right? You don't have to flip anything because we haven't multiplied or divided it yet. All right, now how do we get that x by itself? What do you have to get rid of? The negative sign. How do you get rid of a negative? Multiply by -1. Okay, watch this. So if I do this, I have to do this, and I have to do this, okay? Because I'm multiplying or dividing by -1. So x is greater than or equal to -2. Okay? Is that what you guys got in the back? Thank you for your humility. Next time, speak up. Brag about your right answer. All right. I'm smiling. I'm not like getting mad at you.
You want to squint your eyes when you smile?
I know. I smile different now because of my mask. So people need to know that I'm smiling. I'm like, you know what else I've noticed about wearing a mask? Is it's forced me to be extroverted. I could just like walk by somebody, because usually in the past I walk by and I smile. You know, it's a nice, polite thing to do, right? But they can't see me smile, so I have to actually talk to them. So I have to say, hi, how you doing? And I keep walking my dog. No, I'm fine. I can be extroverted, but masks do that. So they either do 2 things. You either go way more isolated, and now you're like really rude to everybody, or it forces you to be a little more extroverted. Weird, huh? Okay, moving on. 1 more. Let's see if you can do this. This is redemption. This is example 3. I want you to graph -3x plus 4 is less than or equal to 13. Okay, so solve this normally. And then if you multiply or divide by a negative number, which you will, then flip the symbol. And it's usually the
Wait.
last thing you do. in
Should
an
we
equation.
make a number line?
Yep. And
Okay, that's how we.
so after you solve it, get the x by itself, then graph it. Oh, and we forgot to graph this, but this is just a -2 here. Fill in the dot, shade to the right. To catch up with you 1 second.
Okay, I haven't grabbed it yet. This is my answer that I got.
Okay, so the only thing you did wrong is, so everything is right, except see how you divided by a negative number?
Yes.
So that symbol needs to be reversed.
Okay, I didn't.
It's a weird rule, but you have to do that. And that's the part you missed.
Reverse, as in, does that get rid of the?
Just switch directions. No, it
Oh,
doesn't get
okay.
rid of the line underneath.
Okay.
It's not like a negated inequality. You just have to reverse direction.
Mhm.
All right. You girls want to brag about your answer? What'd you get?
I got x is less than or equal to -3.
So I'm gonna do this, which means you shouldn't have bragged. I'm just kidding. Yes.
X is greater than or equal to -3.
Okay, there it is. So you forgot to flip the symbol.
Okay.
Because you're dividing by a negative, you eventually, after you get rid of everything, you divide by a -3. So do you see that?
Yeah.
So that's a very common mistake, and I know it seems like a silly rule, but if you think about it, you could put the x over here, and it's a positive 3x over here, right? But then look, see how the alligator point opens towards the 3x. But over here, the alligator is pointing the other way. So that's why you flip the symbol. It's just a shortcut, but you could just make sure that x is negative or positive by putting it over on that side. But then you have like a reversed inequality, and then that's confusing. Okay, so let's do this. -4, -4. I think most of you got this far. Less than or equal to 9. And then we're dividing by a negative. If it was just a 3, then we wouldn't have to flip it. But it's a -3. So greater than or equal to -3. So then graph it. Throw a -3 on a number line somewhere. I don't care about anything else. You don't have to fill in any more details. We're not doing like domain, like just integers greater than or equal to -3. If it's all real numbers, just put a -3 on a number line and shade left or right, and then figure out whether you should fill it in or not. Okay, we didn't do any inequalities where you didn't fill it in. They were all greater than or equal to or less than or equal to.
Wait, so if it gives you a, what's it called? If it gives you a domain, like say if it gives
Yeah.
you an integer domain, do you have to draw the dots?
Yeah, so you have to do, if it was integers, you'd have to go -3, -2, -1, and then just dot, dot, dot.
Would it ask you to do that, like where, like, what's it called? Like, I don't know if it's a function box, if that's what it's called, but where you have to like, it's like an equation inside a square root, so it'll be like,
Like a radical equation?
yeah, so like x minus 4 all inside a radical, and it'll be.
Yeah, those are radical equations. Have we talked about those? Yeah, so
we've been doing those.
basically you just square both sides. You have to get the radical by itself and square both sides, and then it's a normal equation. Then you can keep going. But yeah, but we'll go over that, especially when we review for our last test. But and I was going to find out what our last test was, so we can know whether we need to stress out about this stuff. Yeah, because I think our last test, because we're going to 100. But if we do test 24, then that's going to go all the way up to 95. But I don't think we're doing 24. I think we're doing 23. So then,
I think it's 24.
Is it 24?
Schoology.
Okay, so you do need to know this. Okay, but this is okay. This is good. Just flip the symbol.
Are we
Flip
gonna
the flipping
do
symbol.
the thing we did last semester where if you have an A, you don't have to?
Yep, we
We
are. Yep, so we'll find out here in a sec. Okay, so let's talk about spheres and cones. Here's the deal. I'm just going to give this to you. This is a cone, right? The volume is going to be 1/3 pi r squared h. Okay? Because remember, this is just kind of like a cylinder of the same height. Okay? But this is only 1/3 of that. It's kind of like a pyramid. Do you remember talking about that? Where if you have a pyramid and then like a prism of the same height, it's just 1/3 of that prism. This is 1/3 of that cylinder of the same height. It kind of doesn't look like it because how can you fit 3? Well, if this was made out of if this was a sugar cube and that was a can, you could ground it up 3 of those and it would fit perfectly in that cylinder. Okay, it's true. So 3 of those equals 1 of those. Now spheres are different. Spheres look like this. And the formula to find the volume of a sphere, you need to write down because it's hard to remember, 4/3 pi r cubed. 4/3 pi r cubed. There's no h in there because the radius, well, I'll tell you in a second. Here's how I explain it to people. If you forget about it, you can kind of use your best guess to figure out the formula. If I were to break this in half, then it would look like this dome, okay? So technically that would be 2/3 pi r cubed, right? Well, if this is radius, what's this? That's the height. But what's the height of that hemisphere? The same radius. So that's why it's pi r squared h, but h is radius, so that's why it's pi r cubed, okay? But this kind of looks like a cone, in between a cone and a circle, right? Or a sphere, or in between a cone and a cylinder. So it's a chubby cone. A cone is 1/3 pi r squared h. So the hemisphere is going to be 2/3 pi r squared h. Okay, so see how this is like halfway between a cone and a cylinder? Do you see that? So it's kind of, and again, it's not an exact science, but it's a good way to remember it. Well, if this is 2/3 pi r cubed, well, 2 of them would be 4/3 pi r cubed. Okay, you don't have to know how I did that, but if you forget, you can kind of use what you already know about cones and cylinders to figure out this formula. Okay. Now, what I can't tell you is why the surface area is 4 pi r squared. That's it. 4 pi r squared. 4 circles. Because pi r squared is the area of 1 circle. But why the heck does the surface area equal 4 circles? And this is the circle, this is called the great circle. In a sphere, the biggest circle is called the great circle. So on our planet, that equator, right, is like the great circle. And you guys know that it's not actually a sphere? Okay. But, so if you can figure out why and explain to me, kind of like how I explained this, why surface area is 4 pi r squared, I'll give you gobs of extra credit. But I haven't heard a good explanation yet on why that's the case. It's really cool. Yes.
Do you is it because it's split up into 4 maybe?
Yeah, but like if you were to wrap this present, why is it just 4 of these circles. Like, could you cut them out? Could you do something? So see if you have any kind of graphic design program, you might be able to figure that out and show me, but explaining it logically, I can't see it. Okay, so if you got something, put it together. I'd love to see it. And then I'll tell every student for the rest of my life your idea and your explanation. Okay, that's 91. Let's move on to 92. Okay. See how it's getting cleaner, slowly. All right, now we're on uniform motion. This is what I've been hinting towards for the last few weeks, but this is uniform motion. This is a lot easier now because you know systems of equations. So you know how to solve for 2 variables, and really you don't even have to do that because it's just substitution. They're already going to give you an equation where you can either manipulate it so you can use substitution and plug it in, or they're going to give you like time 1 is time 2 plus 5 or whatever. Okay, but let's just start with an example. Okay. All right, I'm going to write this out because it's important. Express train made a trip in 12 hours. So right there, what you can do before you even go any farther, that's a time. So remember, we're talking about distance, rate, and time. So is 12 a distance, rate, or time? It's a time. So we're going to say T subscript E equals 12. See how easy that is? So time of the express train is 12. So far, so good? Now we can forget about this sentence. Who cares? Next sentence. Next day, the freight train, so that looks like a subscript F, right? Freight train made same trip. What does that mean? Equal. Okay. Same trip in 16 hours. Okay. Now what can we say? Freight train made the same trip in 16 hours. Micah?
T subscript F equals 16.
Yes, T of F equals 16. All right, now, next sentence. If each train, find the rate of each train. So we're going to find R subscript E and R subscript F. If the freight was 15 kilometers an hour less than the express train. Okay. So we're going to say that. We're going to say freight train was 15 kilometers an hour less than express train. How do you say that? How do you say freight train was 15 kilometer hours less than express train? Nathan?
TF plus 15 equals TE.
Not T.
Oh.
This what's this?
Rate.
A rate.
R.
So R of F. You could say plus 15 equals that, but you could just translate it directly. Freight train was equals 15 less than, remember that's something minus 15, not 15 minus something, express train. You see that? Look at that. I just translated that. Do you see the translation? Okay. So now I don't care about the train. I mean, good for them, but I have some information here. Now, the last thing you need to do, or maybe the first thing, sometimes I will draw a diagram. Okay, here's the station. Okay, and they left. So this is the express train. So this is the distance of the express train. But it's the same trip. So that's the same distance of the freight train. So guess what? What can we say about the distances? Do you have a question or?
A question. What was the formula for surface area of a sphere again?
4 pi r squared.
Okay. Squared or cubed? Squared, right?
Yeah, because it's 4 circles. Pi r squared is a circle, so 4 pi r squared. Okay. So what can we say about the distances? What do they look like? What is this distance compared to this distance?
They're the same.
Yeah, so we can say d of E equals d of F. All right? Okay, so that could be the first thing you do. Okay, is this one of those problems where the distances are the same or where they're different? Well, for this week, they're all going to be the same until the next time we talk about uniform motion, which is on Tuesday. It'll be the next lesson on Tuesday, 94. Okay, so now this is going to be your equation all the time until Tuesday night. Okay, or probably the next Monday night. So next thing, replace the D's with R's and T's. So what does D equal to? Remember dirt? Distance equals rate times time. So D of E equals R of E, T of E, right? R of E times T of E. You got that? Okay, so this is going to be your equation. You don't even have to write down the D's. You could just write R of E, T of E equals R of F, T of F. Now is the fun part. Now we get to substitute what we know and solve for what we don't. What's R of E? Do we have that?
It's no.
Nope. We have this, we have this, we have this, but we don't have R of E. So that's going to be the one that we solve for. That's going to be our unknown. Do we have T of E?
Yes, it's 12.
Yeah, it's 12 right here. See that? So T of E is there. So I'm going to substitute it right there. I'm going to just put 12 R of E because I like to have the number first. All right. Do we know R of F?
It's RE minus 15.
Yeah, so we can substitute this phrase in right there. So this is R of E minus 15. And then T of E, remember? Or T of F, what's T of F? 16. So there's my equation. So I mean, technically T of F is on the right, but you know what I mean? I don't like putting the number over there. Doesn't matter what order you do it in. So now I've got this. I just have one variable, so now I can solve it. So I have 12 R of E equals 16 R of E minus 240. $250. 240. Definitely 240. See what I did? Okay, now I'm just solving this. So add 240 to both sides. Oh, actually, I'm going to subtract 12 R of E. And I'm going to add 240 to both sides. I'm kind of doing it both in one step here. So I get 240 equals 4RE. So divide by 4. Rate of express train is 60 kilometers per hour. So if the rate of the express train is 60, what's the rate of the freight train? That's the express train. What's the freight train?
Oh, no, not negative, sorry.
It's
6 in my head.
60 minus 15.
Yep, which is, what is that, 45? So rate of freight train is 45 kilometers an hour. And that's it. Okay? So you don't have to rack your brain trying to imagine these little trains, the little engine that could, trying to get up that hill, trying to picture these trains leaving. Now it's going to be, there's going to be other problems where they go in the opposite direction. And then it's going to say, when will they be 100 miles apart type of thing. So that's another one. That is a D1 plus D2 equals 100. But we'll get to that later. For now, just set the distances equal to each other. Okay? I'm just going to read this out loud, and you can look in your book and follow along. If you watch this video, you can follow along in your book. But here's the deal. Girl Scouts hiked to a lake at 2 miles per hour. Okay? They hiked at 2 miles per hour. So I'm going to say, first of all, I'm going to say our rate of hiking is 2. You see what I did? I just translate that sentence. They drove home at 12 miles per hour.
Really, really slow.
Well, it's a mountain hike. Okay, so rate of driving is 12. You see how I'm doing this, guys? All right, the next sentence says, find the hiking time if it was 5 hours longer than the driving time. How do you say hiking time is 5 hours longer than driving time?
Is it RH equals 5?
But
plus-
now you're still on rate, but we're talking about time now. So T of H, right? Do you see why? So the hiking time, not the rate, but the hiking time was, what were you saying?
So T of H equals 5 plus RD.
Yep, or T
TD.
of D. Yep, time of driving. Okay, so it's going to either give you rates like it does here, or it's going to give you like rate like this. It's going to compare one rate to the other somehow. Okay, sometimes it'll say if the whole trip was 17 hours, then how long was each interval, basically? So they could say time of hiking plus time of driving equals 17, and then you just have to get one of those variables by itself, just like a substitution problem. Okay, but you have all the information you need. So now we can set these equal to each other. Remember, D of H equals D of driving because it's the same hike in, the same distance in as it is back. Okay, it doesn't say that they went on little single track trails. So hopefully they didn't take their Forerunner down a single track trail. But maybe they hiked on a road. So RHTH equals RDTD, right? You see why this? So I just replaced my D's with R's and T's. Now I can start filling in the blanks. This equals 2. So 2. T of H, we have a T of H. 5 plus T of D equals RD, which is 12. And then TD is our unknown, so just leave it. See how that still says R of H, T of H equals R of D, T of D. Okay? Simplify and solve. 10 plus 2 TD equals 12 TD. Get rid of the 2 TD. So then we get 10 equals 10 TD. So the driving time was 1 hour. So if the driving time was 1, what's the hiking time? 6, right? All right, there is one more problem, but how about we do this? I'm going to give the problem to you, and then if you can get it, then you don't have to do one of these problem sets. Does that sound good? Or basically a free problem set.
Is that for everyone in the class?
Yep, and you guys can work together. All right, so I'm going to put the problem on the board, and you can work together to solve it. So I'm going to get rid of this. Oops, I'm using that one.
Do we all have to do the same answer? That's
If you disagree, that's fine, But I would at least ask and see if you get the same answer, right? Because if all of you get the same answer, it's probably right. Okay, so here it is. Durant drove to Oasis in 2 hours. Medill walked in 10 hours. Okay? So basically they left from the same place. It's the same distances, right? It's that kind of problem. All right, how far? So the question you're asking is the distance. So once you get the rate and time, all you have to do is multiply the rate and time by either one of them, and they should get the same distance. Okay, how far was the oasis if Durant drove 16 miles per hour faster than Medill walked? Okay, so that's the question. So I'm going to leave you guys to it.
Black math, give me some math and I'll give you some flack. Black math.